Hi there, this is Mr. Alexander. Last class we were talking about how to write quadratic equations from data. Now I'm going to show you how to take that equation that we wrote, looks like these four things, and how to write them in vertex form so that we can start identifying key attributes about these functions here. So let's take a look at this equation, y equals x squared plus 6x minus 7. I know that's a quadratic function because it's got the squared up there. And we can write quadratic equations as in vertex form by doing something called completing the square. And the first step to completing the square is getting just the x squared and x terms by themselves. So I'm going to move that negative 7 over to the other side. I'm going to do plus 7 on both sides. So that's going to become y plus 7 equals x squared plus 6x. Now, what we need to do, the first step is on the right side here to create something called a perfect square trinomial. To do that, and I'll explain what that means in just a moment here, but to do it, you take this coefficient in front of the x, you split it in half, and then square it. So half of 6 is 3, squared is 9. So I need to add 9 to both sides. X squared plus 6x plus 9. And then I'll have y. When I add whatever I do to one side, I have to do the other side. So I already got plus 7 plus 9. That's plus 16. Now the reason that we want to create this thing that's called a perfect square trinomial is because when we factor it, it's got this unique property. When you factor this thing, which you may remember from Algebra 1, it becomes y plus 3 times x plus 3 times x plus 3. And I've still got the y plus 16 over there. Now the reason that I want to do that is because you'll notice that both these factors are exactly the same. So I can actually rewrite that as x plus 3 squared because they're the same. So I've got y plus 16 equals x plus 3 squared. Now, what I'll want to do to get this thing into vertex form is I want to subtract the 16 over there. Y equals x plus 3 squared minus 16. Now you might be asking, what's the point of all that? Well, the whole point is to identify the vertex of this thing, which we're going to talk about a lot more in another class. But for now, you can just recognize that the vertex is an xy coordinate, and that coordinate, the y coordinate, is negative 16, and inside the parentheses here, this is counterintuitive, so the x coordinate is negative 3. So we've been able to write this thing in vertex form, and the whole point of doing this thing is just so that we can easily identify key attributes of this function. So this is vertex form, this is the vertex. Now a nice way to double check that you've done this correctly is in your calculator, go ahead and type in both equations, the original function, the x squared plus 6x minus 7, and type in x plus 3 squared minus 16. And when you graph them, they should be the exact same function. If you only see one curve, then you've done it correctly. If you see two, then it's not correct. So that first one was kind of like, okay, that's the first time I've ever seen that. That's kind of weird. Let's do it again. So we've got this standard form equation, y equals x squared plus 4x plus 10, and I want to write it in vertex form. I do that by completing the square. The first step is to get the x squared and the x term by themselves. So we're going to take that plus 10, we're going to move it over to the other side. y minus 10 equals x squared plus 4x. And now from here we need to create a perfect square trinomial. So I've got the x squared, the 4x, and the way we create a perfect square trinomial, cut that coefficient in front of the x in half, make it a 2, and then square it. So 2 squared is 4. So I'm going to add 4 to both sides. So I've still got my y. Negative 10 plus 4 is negative 6. Okay? So from here, we have a perfect square trinomial. And now we're just going to go ahead and recognize that as x plus 2 squared. Now if you don't believe me that that's a perfect square trinomial, and you take that x plus 2 squared, rewrite it as x plus 2 times x plus 2, and go ahead and FOIL that out. X times x is x squared, 2 times x is 2x, 2 times x is 2x, 2 times 2 is 4. You can write that as x squared plus 4x plus 4. You can see that these two things are the same thing. So that's the property of a perfect square trinomial, is you can rewrite it in this convenient way. All right, well, to get this thing into vertex form, we're going to add the 6 to both sides. X plus 2 squared plus 6. So this was the standard form. This is the vertex form. And from that vertex form, we can begin to identify key attributes. One of them, the most important one, is the vertex. And in this case, the vertex, the y-coordinate is the 6, the x-coordinate is the 2, but it's counterintuitive, so it's going to be negative 2. How can we double check it? Let's go to our calculator, type in both equations. X squared plus 4x plus 10, and we also got x plus 2 squared plus 6, and I'm going to make the second line darker. So if I see only one equation, then I've done it correctly, and it looks like I have. And the good news is you can see that the vertex is at negative 2, 6, so we can feel pretty good about that as well. All right, so completing the square comes with varying degrees of difficulty. So let's show you two more that are slightly more challenging. So here, the first step is the same. Let's get the x squared term and the x term by themselves. So I'm going to add 8 to both sides. I'm going to get y plus 8 equals negative x squared plus 2x. Now, here we have an extra step. Before I can make anything a perfect square trinomial, I need to get rid of that negative. I need to divide both sides by negative 1. So that's going to change everything to negative y minus 8 equals positive x squared minus 2x. Because I don't want anything in front of the x squared. This is a lot easier to do if you don't have anything in front of the x squared. So now this looks like something I can turn into a perfect square trinomial. What's half of negative 2? Well, that's negative 1. Negative 1 squared is positive 1. So I'm going to add 1 to both sides. I've got a negative y. Okay, I've got a negative 8 plus 1. That's negative 7. This is a perfect square trinomial. So I can rewrite it as x minus 1. And the way I got that 1 is I just took negative 2 and cut it in half. X minus 1 squared, and I've still got this negative y minus 7. All right, well now I need to add that 7 to the other side. Negative y equals x minus 1 squared plus 7. And I've got a negative in front of the y, so I'm going to multiply both sides by negative 1. That's going to give me positive y equals negative x minus 1 squared minus 7, because that negative 1 distributes to both the terms inside there. So here was my standard form. This is now my vertex form. I know I'm in vertex form because the y is by itself, and I've got this nice, pretty looking vertex right here. So the vertex is going to be positive 1, negative 7. That negative in the front doesn't change anything that's going on inside of the parentheses there. What that negative in the front there does is it makes it go upside down. So let's just graph it so you can see it. The standard form was negative x squared negative x squared plus 2x minus 8. And the vertex form was negative x minus 1 squared minus 7. And I'm going to make that second equation nice and dark. And you can see that this thing's going to open downwards, and that I went ahead and found the vertex at 1, negative 7. Okay, so that's a nice way to double check. Okay, last one here. We've got the standard form of the quadratic equation right here. This is what we were able to write last class from data, and now I'm going to turn it into the vertex form. The first step is to subtract the 5 so that we have the x squared and the x terms by themselves. So I'm going to change this to y minus 5 equals 4x squared minus 2x. Well, I told you in the last problem, we don't want anything in front of that x squared term. So we need to factor out this 4. Here's how you do that. Y minus 5 equals 4 times x squared minus, now I factored out a 4 from 2, so 2 divided by 4 is 1/2. So I have x squared minus 1/2. Okay? Now I want to get this x squared, oh sorry, I forgot my x right there as well. Now I want to get this x squared, I want to get everything inside the parentheses by itself, so I'm going to divide both sides by 4. So that's going to leave me with y minus 5 divided by 4 equals x squared minus 1/2 x. Well, I want to turn this into a perfect square trinomial, and the way you do that is you split this coefficient in half. Half of negative 1/2 is negative 1/4, and then you square it. And if you're thinking, oh no, what's negative 1/4 squared? Well, we can just do that in the calculator. Negative 1 divided by 4, enter, squared, math, enter, enter, is 1 over 16. So I'm going to add 1 over 16 to both sides. This thing is now a perfect square trinomial. Keep the left by itself, or the way it is, I mean. And the right, we can rewrite it as x minus, what's half of negative 1/2? That's 1/4 squared. Okay, now that I've got this thing nice and pretty right here, I can start getting the y by itself. So I'm going to subtract 1/16 from both sides. So I'm just going to do that right here. Minus 1/16. And now I want to multiply both sides by 4. So times 4 times 4. That's going to leave me with y minus 5 equals, I've got 4 in front of x minus 1/4 squared. And then negative 1/16 times 4 is negative 1/4. All right? The last step is to add 5 to both sides. So y equals 4 times x minus 1/4 squared, and negative 1/4 plus 5 is positive 4 3/4. Or if you prefer, 4.75. So from this, I can get the vertex, now that I have it in vertex form. I can get the vertex, and it's simply positive 1/4, because inside the parentheses is counterintuitive, comma 4 3/4. And we should always double check it by graphing both of them. So I'm going to do that right now. So let's double check it. Let's go to y equals, we'll type in the standard form, which is 4x squared minus 2x plus 5. And the vertex form was 4 times x minus 1/4. I'm just going to make that 1/4 to 0.25 squared plus 4 3/4 is 4.75. So when I graph that, hopefully I just see one equation. There's one, and there's the other. So I know I've done it correctly. So that's it. That's how you're going to complete the square to write things in vertex form. Thank you for watching. I hope this was a useful experience for you, and I'll see you in class. Thanks for watching.